All right, we just have a few minor points to finish chapter 12. And I'm going to start by giving you a couple of practice problems here, you can all attempt. And then I'll finish the last couple of points that I have to talk about in regard to chapter 12. So the first problem I'm going to give you is following. Total bank deposits in the economy equal 10 million. The required reserve ratio is 10%. The Fed buys bonds worth $1 million from the public. What will be the resulting change in the money supply, assuming banks are fully lent up and there are no cash leaks. This basically means that the desired reserve ratio is equal to the required reserve ratio and that the cash to deposit ratio is 0. Correct? So let's attempt this question. And I'll give you another one after this. And then I'll proceed to talk about the last few points that I've missed in chapter 12. But it's a formula that involves the money supply changing, the Fed buying bonds, right? What does that do to the monetary base? Do you remember what the monetary base is? The monetary base is defined as cash with the public plus the reserves of banks. Right, and what's the formula we're looking for here? The formula we're looking for is the change in the money supply is equal to the change in the monetary base times the money multiplier. Is that correct? So how do you tackle this? So if the Fed's buying bonds, what is that going to do to the monetary base? Well, think about this. If the Fed is taking your bond and giving you money, what will that do to cash with the public, for instance? You are part of the public, isn't it? When the Fed's buying your bond, taking your bond, giving you, let's say, cash, wouldn't that bump that up? Yes? And then you're going to take some of that money and, or maybe all of it, and deposit it in your bank. And once you deposit it in your bank, it'll cause this to bump up, you see? So the point here is that when the Fed buys bonds, the monetary base rises. So in our case here, the Fed's buying bonds worth 1 million from the public, so the change in the monetary base is going to be how much? Plus 1 million, isn't it? Because the Fed is buying bonds worth $1 million, giving you $1 million cash, which is going to bump up the monetary base by $1 million. Is that right? So we know what the delta monetary base is, change in the monetary base. It's plus 1 million. The plus comes from the fact that this is an increase, isn't it? A positive change is an increase, right? Okay, what about the money multiplier? What's our formula for the money multiplier, somebody? Feel free to refer to your notes, your textbook, you know. So what's the money multiplier? The full formula for it. We have an abbreviated formula and then we have a full formula. Do you remember the full formula? One plus, that's right. Correct? Where C is what? C is the cash to deposit ratio. Right? And R is the desired reserve ratio. However, in my question here, I say that assuming banks are fully lent up, what does that mean? This means that banks are going to be lending the maximum that they are allowed to by the Fed, which means that the only reserves banks keep are required reserves, correct? So essentially that assumption means that this desired reserve ratio is in fact equal to the required reserve ratio. This comes from the fact that banks are fully lent up. Now, what about the cash to deposit ratio? So we're assuming here that there are no cash leaks. What does that mean? That means whenever any party receives a sum of money, he or she deposits the entire amount in the bank, keeps no cash. So there is, the cash to deposit ratio then is how much? 0. So this here would be 0 since no cash leaks. Right, so we know what this whole thing is going to boil down to then, correct? So this can then be worked out as plus 1 million times 1 plus 0 divided by, what's the desired reserve ratio? It's equal to the required reserve ratio in this case. And the required reserve ratio is how much? But we need to convert that into decimals, correct? So this would be 0.1 plus 0. Right, so this is then plus 1 million times 1 divided by 0.1, which is plus 1 million times 10, or plus 10 million. Right? So what's the resulting change in the money supply? What is this change in the money supply going to be then? This change in the money supply shall, according to our calculations, be equal to a rise of $10 million. Right? How do we know it's a rise? Because this is a positive change. Are we getting a sense of this? Your next exam is going to contain problems like this, okay? All right, another problem now. Or let me just pause a second for you to write this down. Here's another problem. Total deposits in the economy equals, let's say, 200 million. The RRR is 15%. The desired reserve ratio equals the required reserve ratio, and the cash to deposit ratio is 0. So banks are fully lent up and no cash leaks, okay, to keep things simple. Now, the Fed lowers the RRR from 15% to 10%. Could you calculate the change in the money supply? Once again, we will have to use the formula that we put up on the screen before, right? The one involving the monetary base and the money multiplier, right? So how is this going to work? So by that formula, the change in the money supply is equal to the change in the monetary base times the money multiplier. Is that correct? But in this particular question, this equation will change a little bit. And it'll change in the following way. In this question, since the Fed is not buying bonds or selling them, the monetary base is going to remain unchanged. Because the monetary base, remember, is cash with us, the public, and cash lying in banks' reserves. And the only way this can rise or fall is if the Fed either buys bonds or sells them. So in our story here, this delta is actually going to be 0. So we're going to leave the monetary base unchanged, really. What is going to change here is the money multiplier. That's going to change. And that's going to change, why? Because of the RRR changing. Remember, this is equal to, in our simple story, it'll be 1 divided by the RRR. And the RRR is changing. That's changing. So that's going to cause the money multiplier to change. So basically then, it's a variant of the previous formula. Instead of having the monetary base change, the monetary base remains unchanged in this case because the Fed is neither buying bonds nor selling them. But what is changing is the money multiplier, right? All right, then how do we proceed now? What is the monetary base? Now we can figure this out. The change in the money multiplier, what will that be? Yes, well, it'll have to change. How would this change then? 1 by, it used to be 1 divided by 0.15, is that correct? And it becomes 1 divided by 0.1. Is that right? So what is the change then? Can somebody with a calculator do this? So the change here would be, this is the bigger number. Right, that's the change. How much is that? So this, of course, is 10, and that is 6.67, right? So the whole thing is really 3.33 then. Yes? Okay. What's the monetary base? So we know what this is. Now, if you know what that is, then we can multiply the two together to get the change in the money supply. So what's the monetary base? What's the monetary base defined as? Remember in our previous slide, we said that the monetary base was this statement here. The monetary base is cash with the public plus reserves of banks, right? Now, since the cash to deposit ratio is 0, cash with the public is actually 0 in this story. It's all reserves, right? So let's go back to the other slide here. So in our story here, the monetary base is simply going to be equal to banks' reserves. And what are banks' reserves equal to? To begin with, well, 15% of 200 million, isn't it? Because the RRR was 15% and total deposits in the economy was 200 million. And so the cash reserves of banks had to be 15% of 200 million. Right? That's what the RRR is, isn't it? The required reserve ratio is the percent of deposits that banks need to keep as a cash reserve. And in this case, banks have no excess reserves because they're fully lent up. Right? So what's 15% of 200 million? 30. Right? So we have this number here, 13 million. So what's going to be the change in money supply then? 30 million times. Is that right? And how much is that? Yes? So are we getting a sense of how to do problems like this? Because there will be some like this in your next exam. By the way, can somebody remind the rest of us of when that exam is going to be? Is it next week? Next Friday. Next Friday. Okay. Well, we have plenty of time now, so what I'm going to begin to do, I suppose, is review. After I finish, I have one more chapter to do, which I will begin next class. But what I'm going to do today, in the time that I have left, is do that last little thing from chapter 12 that I haven't done as yet. And then on Wednesday, we'll start chapter 17, which will be our last chapter. And once that's done, we will just simply review. So we'll have about 3 classes to review. Okay? All right. So now, to finish up finishing up chapter 12. Right? So up to now, we've learned that the sequence of events that describes, let's say, expansionary monetary policy the sequence of events that describes expansionary monetary policy would be money supply rising. That causes the rate of interest to fall. The rate of interest falling causes consumption spending to rise, investment spending to rise, and also net exports to rise, correct? This causes, of course, the AD to rise. The AD is made up of these three, plus government spending. And that should cause equilibrium GDP to rise. So this is how expansionary monetary policy works, correct? These events happen in the money market. And these events happen in the goods market. Correct? Now, I mentioned in class last time that this connection could be weakened in two ways. First, you could perhaps have this link here being broken. This is the link between the money market and the goods market, and this is called the transmission mechanism. Now, what would cause that connection to be broken? In other words, what we're saying here is that the rate of interest falls, but this fall in the rate of interest doesn't cause, for instance, consumption spending to rise. And we've always said that when the interest rate falls, consumers are more likely to take out business loans to go shopping. Consumer loans to go shopping. And businesses are more likely to take out business loans to go shopping. Why wouldn't they do that? As I mentioned in class last time, this could happen if there was a lot of pessimism in the economy. If consumers were worried about their futures, for instance, if they know that their employers are laying off workers, and so the interest rate may fall, but this would not cause you to go running to buy a new car if you thought you were going to lose your job in the next few weeks. Am I correct? So if there was a lot of pessimism in the economy, then a falling interest rate will not necessarily stimulate shopping by these three shoppers, at least two of them, households and firms, right? Now, the other connection that may be broken is the one here, which is the money supply rises, but the rate of interest doesn't fall. Now, when might something like this happen? Now, this is a very peculiar situation. I'm going to draw the diagram of the money market again quickly. So we have the quantity of money, we have the rate of interest, we have the money supply curve and the money demand curve. I'm going to draw the money demand curve first. And the money demand curve, as we know, is negatively sloped like this. But this money demand curve here has a strange flat portion towards the end. See, as opposed to reducing like this, which is the way we've drawn it before, this money demand curve has a horizontal section towards the end, towards the bottom. Okay? Now, if the money demand curve looked like this, and if, let's say, the money supply curve were like this, then we would have equilibrium where? We would have equilibrium right there. And this would give us an equilibrium rate of interest, R star. Now, if the Fed were to raise the money supply, shift this vertical money supply curve to the right like this, what happens to the rate of interest? They will stay as the same precisely. We're going to have a new equilibrium there, but this will translate to the same rate of interest. So this is what happens when the money demand curve has a flat section. And this phenomenon has a name. It's called a liquidity trap. I'm not going to discuss this in detail here. I'm just going to tell you that something like this could occur, in which case this connection is broken. So whether we have a lot of pessimism in the economy or a liquidity trap, for both of these reasons, money supply could, rather monetary policy could become less effective. So both of these are factors that weaken the effectiveness of monetary policy. Right? All right. Now I'm going to talk about the long run. All of this is really a short-run discussion. And now for monetary policy in the long run. Okay? Now the idea here is that in the long run, equilibrium GDP should in fact equal potential GDP. What's the idea here? Why is that, in a sense, guaranteed in the long run? Well, one argument that has been put forward is this. You see, in the short run, unemployed workers will be choosy. You see, they'll be choosy. They won't take the first job that comes their way, necessarily. Right? But in the long run, what happens is, as people remain unemployed for a long period of time, logically, they become less and less choosy. Is that right? They become more and more desperate for employment, in other words. Correct? So this basically means that unemployed workers become less and less choosy. And this implies that in the long run, there shall be full employment, in the sense that everyone will be employed. When I say everyone, of course, I'm still I'm still excluding the naturally unemployed. But everyone is going to become desperate enough to take a job. That's the idea here, right? So in the long run, we are guaranteed full employment, in a sense, because everyone becomes desperate enough to take a job, any job. So if you have full employment, if everyone's employed, that of course implies that the equilibrium GDP should equal potential GDP. Is that right? So that's the argument here then. So in the long run, we are at full employment. And now I'm going to talk about something called in the few minutes that I have left here, about 10 minutes or so, the quantity theory of money. The quantity theory of money. Now, according to this theory of money, you have something called an equation of exchange. And what is the equation of exchange, which is the principal equation of this quantity theory of money? It is that M, I'm going to write this down and then explain what these things are, okay? M times V is equal to P times Y. And let me explain what these things are. M is the quantity of money in the economy, the money supply, in other words. M1, for instance. Yes? V is called the velocity of money. The velocity of money. And what is the velocity of money? V is basically the number of times a dollar changes hands over a year. So V is a measure of roughly the number of times a dollar bill in our economy changes hands over the course of a year. Now, let's say this bill changed hands just once. In other words, I have a dollar bill and I buy something from you. So it changes hands just once. Of course, when I'm buying something from you, it means that you have produced that item. Right? In other words, that will imply that real GDP in the economy is $1, isn't it? Or you've produced that dollar worth of goods, which you've sold to me, which is why I've transferred that dollar bill from myself to you. Correct? So in other words, this is a measure roughly of the amount of GDP or transactions supported by $1. Right, now, if this dollar bill changes hands, say, 5 times, what would the implication be? In other words, I buy something from you, that's one transaction, one change of hands. And this means that $1 GDP has been produced by you for me, right? Now, let's say you take that dollar and you buy something else from somebody else. That would mean a second dollar of GDP will be produced. Is that correct? So if the velocity of circulation were 5, this would mean that $1 bill in the economy supports $5 of GDP. Is that right? Okay. What is P? P is the, pardon me, is the price level, which we know what that is, correct? It's a measure of average prices as measured by, for instance, the GDP price index. And Y is your GDP. Let's understand this. Okay? Y is real GDP. Okay? Let's put the word real. Now, let me make things real simple here. Okay? So let's say that the only good is apples. Right? And let's say that 100 pounds of apples have been produced. Correct? And let's say that the price per pound is $2 a pound. So by this token then, what will be this side of the equation? P times Y. In other words, what value of GDP has been produced? And we'd have $2 a pound times 100 pounds. So that's $200 worth of goods have been produced. Is that correct? Right? Now, let's say that the quantity of money is equal to $50. There's $50 of $50 bills in the economy. Let's just think about, put it simply. There are $50 bills floating around the economy. Now, for these $50 bills to be able to buy $200 worth of goods, each dollar bill will have to change hands how many times? Each dollar bill will have to support what value of transactions over the course of a year? Well, $50 have to support $200 worth of transactions. Is that correct? So the velocity of money would have to be 4. Am I making sense here? Right? The velocity of money is basically the value of transactions in dollars supported by $1 bill. Right? So if there are $50 in this economy, $50 bills in this economy, and these $50 bills have to be used to, in a sense, purchase $200 worth of apples, well, each dollar bill will have to support how many dollars of transactions? $4 of transactions. Is that correct? So the velocity of money is 4 in this case. So this is our equation of exchange. Is that understood by you? So the quantity of money times the number of times the dollar bill changes hands, these two must equal the value of real GDP produced in the economy. The goods that need to be bought, in other words. Okay? Now I'm going to rearrange this in the few minutes that I have left and tell you where this is roughly going, okay? So once again, I'm going to write the equation of exchange. MV is equal to P times Y, right? I'm now going to rearrange this as follows. This can be rearranged as P is equal to MV divided by Y. Correct? Now in this equation of exchange, two things are generally considered to be unchanged. The velocity of money. This is something that doesn't change very much. It is roughly a constant at any point in time. Next, we said that we are in the long run, right? And in the long run, what's true? Y is equal to YF, isn't it? So this Y is really YF, and that too is then fixed. So V and YF are fixed. So the only things that change really are the P and the M. Is that correct? Right? Now, let's say that M goes up by 10%. If M goes up by 10%, could you calculate for me the percent change in the P? What would this percent change be? Well, so really what we have is, since V and YF are constant, we really have it, we can write it like this: P is equal to M times a constant. Is that right? So if this goes up by a certain percentage, wouldn't P go up by the same percentage? Right? So what this is roughly telling us is that the rate of inflation, and what is the rate of inflation? The rate of inflation, of course, would be the percent change in the price level. That's how we define the rate of inflation. So the rate of inflation, according to the equation of exchange, shall equal the percentage change in the money supply. So what this is basically saying is this is, in a sense, a warning. This statement here is a warning. It's a warning to the Fed. And what kind of warning is it? Basically, it's warning the Fed, that if the Fed raises the money supply rapidly, then there should be high inflation in the economy in the long run. Correct? If the Fed starts to make this very large, if the Fed starts buying bonds in a big way from the public, for instance, right? If that were, for instance, a large percent change from year to year, then according to this equation of exchange, we should also have an equally high rate of inflation. And is inflation a good thing or a bad thing? We've learned that inflation is undesirable, right? We have three goals for the economy. And the three goals, if you remember, are: one, low unemployment. The second one is to have low inflation. And the third goal is to have a high rate of growth. So low inflation is the desirable. So what this is saying is that the Fed had better not increase the money supply too rapidly. Otherwise, there will be high inflation. Okay. And that's really all I have to say on the subject. And we'll stop here today. And next class, we will start chapter 17, our last chapter. Okay? Stop here.